per liter of solution, right? What I have written? Number of moles of solute present in per liter of solution. That is a simple definition of this molarity. Molarity is your capital M, represented by capital M. When we express it mathematically, then what we write? This molarity, capital M, is number of moles. Whose number of moles? Of solute divided by volume of solution in liter. So volume of solution is in liter, right? Is the simplest one. Normally what happens, there are different units to represent the volume of solution. The common unit which we use is liter, milliliter, right? So if we change it in terms of milliliter, the volume is expressed in terms of milliliter, then you have to rewind here. Molarity is equal to number of moles of solute into 1000 divided by volume of solution in milliliter. So that is another term. अगर मिलीलीटर में होगा तो हमको 1000 से इंटू करके वॉल्यूम ऑफ सॉल्यूशन को मिलीलीटर से डिवाइड कर देना, right? Also, as we have discussed about this moles in class 9. So when you define mole or when you express mole mathematically, what happened there? A mole is number of moles is equal to the mass of component, the mass of solute. I am writing here solute. So mass of solute and divide by molar mass of solute. So molar mass of solute. If it is term of your atom, then it will be atomic mass of solute. If solute is in terms of atom, then atomic mass only there, right? So what is the third one definition of molarity is equal to? What is molarity? Is number of moles. So in place of number of moles, you write here mass of solute divided by molar mass of solute into volume of solution in milliliter into 1000. So this is your another definition of this molarity. So different terms are used to express this molarity, right? So molarity is equal to what we have written. So mass of solute into 1000 divided by molar mass of solute into volume of solution, right? So this is the fourth way to represent the molarity of solution. Also, if we talk about the molarity in terms of weight, in terms of mass, what is there? Molarity is equal to W1 into 1000 and divide by M1 into V, where W1 is the weight, is the mass of solute, and M1, capital M1 is the molar mass of solute, and volume of solution is V, and so is milliliter, and therefore you have to multiply by 1000. So molarity is equal to W1 into 1000 divided by M1 into V. Suppose I have to ask a very simple question, calculate the molarity, is for only as a symbolic term. Calculate the molarity when, right? I am writing the question here. Calculate the molarity when 4 gram of sodium hydroxide is dissolved in, very simple one, in 250 milliliter of water. Water is the solvent. So 4 gram of sodium hydroxide, the name of solute is your sodium hydroxide, Solvent is water, so is water. What we call W1, W1 is 4 gram, volume is in milliliter, so volume is equal to 250 ml. We have to calculate capital M, that is called your molarity. We have to calculate molarity, so M is equal to what? And before that, you calculate the molar mass. So M1 of which one is the of sodium hydroxide. So M1 of sodium hydroxide. So you first calculate, you have to calculate the molar mass of sodium hydroxide. So what is mass of sodium is 23, calculate immediately, and 16 plus 1. So that is 40 gram. Right, so M1 is 40 gram. So the molarity of solution is equal to W1. W1 is your 4 gram into 1000 divided by molar mass is of 40 gram and the volume is 250. So is 4, 10, right? So is 10 by 25. 10 by 25 is the molarity of solution, right? So 10 by 25 is 0.4 gram. 0.04 is the molarity. So you calculate it, 10 by 25. We have multiplied it by 4, so is 40. 25 by 4 is 40 by 100. 40 by 100 is equal to 0.4. So 0.4 only, 0.4 is the molarity, right? So this is the simple one. You have to solve different numericals related to this molarity, right? The next term is your molality, right? Next one is your molality. So I am writing the next one is the molality. What is the case of molality? There is slight difference in terms of molarity and molality. Molality is said to be of temperature free, and so that is a better unit to represent the concentration of solution in compared to molarity. So molality, this is your molality. It is represented by a small m, right? This is the number of moles of solute. Again, number of moles of solute present in 1001 kg of solvent. Here is the mass of solvent. So 1 kg of solvent, 1000 gram of solvent, whatsoever the case may be. So this is called your molality, a small m, right? So molality is represented by a small m. A small m is equal to number of moles in the same way, number of moles of solute divided by mass of solvent. If you write mass of solvent in kg, there is no need to multiply. If you write in terms of gram, then multiply by 1000, right? So two mathematical terms I have written here. Mass of number of moles of solute into 1000. 1000 is there if the mass of solvent is expressed in terms of gram. So mass of solvent if represented in kg, so molality is equal to number of moles of solute divided by mass of solvent in kg, right? There are, in the similar way as you have defined in terms of molarity, molality also may be represented as mass of solute into 1000 divided by molar mass of solute into mass of solvent in gram. So mass of solvent in gram. So that is the simple definition again of molality. Mass of solute into 1000 divided by mass of solute into mass of solvent, right? This is the fact that the molality is better unit to represent the concentration of solution in compared to molarity, because there is no inclusive of this volume, there is only mass, all are present in terms of mass, and that mass is temperature independent. In case of molarity, what was there? There was volume, and volume can change with respect to temperature, and therefore you always remember it that molality is better unit to represent the concentration of solution. One more important term which is not written in your book, NCERT book, is normality, right? So I am going to discuss another way to represent the concentration is your normality. So what is normality? Normality is like molarity, capital M. The normality is expressed in terms of capital N. So I am writing here normality. Normality कैसे लिखोगे आप? कैपिटल N से. कैपिटल N को कैसे डिफाइन करेंगे? तो इज नंबर ऑफ मोल्स नहीं लिखना, नंबर ऑफ ग्राम इक्विवेलेंट ऑफ सॉल्यूट, राइट, present in per liter of solution. So is per liter of solution, that is in terms of volume. हमने क्या लिखा नॉर्मलिटी के केस में कि नंबर ऑफ ग्राम इक्विवेलेंट ऑफ सॉल्यूट present in per liter of solution, right? So how you have to define how this gram equivalent is different from number of moles, right? So in normal way, when we write this normality, so normality is equal to, write like that, number of gram equivalent of solute, number of gram equivalent of solute, and divide by volume of solution. If it is in liter, no need to multiply there. If it is in terms of milliliter, then you multiply by 1000, right? This is similar to that of molarity, but there is only difference is in that case molarity there is number of moles of solute and there is number of gram equivalent of solute. So we have to, as we have written number of moles, what we have written, number of mole is equal to mass of solute divided by molar mass of solute. So number of moles. In the same way, when we have to write about the number of gram equivalent of solute, you have to remind it, this number of gram equivalent of solute, number of gram equivalent of solute, that will be equal to mass of solute, so that is equal to mass of solute, and divide by equivalent mass, equivalent weight, equivalent mass of solute. So you have to change, in place of molar mass there is equivalent mass, right? Okay, I think you understand what is difference between normality and molarity. So difference is there, number of gram equivalent of solute, and there was number of moles of solute. Number of gram equivalent of solute, that is equal to the mass of solute divided by equivalent mass of solute. So if we define it again, so normality is equal to this mass of solute into 1000 divided by equivalent mass of solute, equivalent mass of solute into volume of solution. So volume of solution is in terms of milliliter. Now the question is, the molar mass of solute is calculated simply, right? I am writing some example to how to calculate the equivalent mass of solute. There are different cases when the solutes are acid, bases, or some salt or ions. It may be different types. So how we have to calculate the equivalent mass of solute, right? So I am going to discuss about that, how we have to calculate the equivalent mass of solute. One by one I will discuss it. Right? So let's suppose I am writing here an example. Suppose just before I have written here how we have to calculate the molecular mass of sodium hydroxide. What I have written, atomic mass of sodium is 23, of oxygen 16, of hydrogen 1, and is 40 U, 40 gram, whatever the case may be. So is 40 gram is molar mass of sodium hydroxide. If I ask you to calculate the equivalent mass of sodium hydroxide, right? To calculate the equivalent mass of sodium hydroxide, what we have to do? We have to calculate the molar mass of sodium hydroxide, and which will be divided by, it is the case of a base. Sodium hydroxide is a base, right? So in case of a base, that is molar mass of base divided by number of replaceable OH minus ion, right? Number of replaceable OH minus ion, or better we can say that if we have to calculate the molar mass of a base, so equivalent mass of base in general, I am writing here equivalent mass of base is equal to molar mass of base, right? Molar mass of base and divide by acidity of base, right? Acidity of base. So what is again acidity? What is acidity? So acidity of base, basicity of acid. So acidity is the number of replaceable OH minus ion. If we talk about this, what I have written, mind it, if we have to calculate equivalent mass of base, then molar mass of base we have to calculate, and then is divided by acidity of base. Because here the number of replaceable OH minus ion in case of sodium hydroxide is 1. And so if we write the equivalent mass of sodium hydroxide, that will be 40 divided by 1, because the number of OH minus ion replaceable is 1, or we can say the acidity of sodium hydroxide is 1, and so the molar mass and the equivalent mass of sodium hydroxide is same, and that is 40, right? For another, if we have this magnesium hydroxide, right? So calculate the equivalent mass of magnesium hydroxide. What we have to do? We have to calculate the molar mass, right? I am writing here the molar mass of magnesium hydroxide, MgOH twice, and divide by the acidity of sodium hydroxide, and the acidity of sodium hydroxide is 2 here, OH2. So the molar mass of magnesium hydroxide divided by 2 will be the equivalent mass of magnesium hydroxide. ठीक है, मैं आशा करूं समझ सकते हो आप. कि मैं क्या लिखना चाह रहा हूँ, मैं क्या बताना चाह रहा हूँ कि जो इक्विवेलेंट मास होगा उसको बेस के लिए मैं अभी एग्जाम्पल की बात किया, तो उसको डिवाइड करेंगे नंबर ऑफ रिप्लेसेबल OH माइनस आयन से, बेटर इन टर्म्स ऑफ डिफाइंड इन टर्म्स ऑफ एसिडिटी, कि एसिडिटी ऑफ एनी बेस इज इक्वल टू द नंबर ऑफ रिप्लेसेबल OH minus ion. If we talk about the equivalent mass of acid, so the second topic is here, equivalent mass of acid. How we have to calculate the equivalent mass of acid? The simple example is, we have HCl, the simplest one, HCl. Calculate the molecular mass is 1 plus 35.5 is 36.5 is the molar mass of HCl. Then its equivalent mass of HCl, that is equal to its molar mass 36.5 divided by its basicity. So basicity is the case of number of H plus ion which can be removed, which can be replaced, and so basicity is 1 here, and that's why it is also 36.5. So molar mass of HCl or equivalent mass of HCl both are 36.5, right? But if we talk about this sulfuric acid H2SO4, molar mass, if we calculate it, is 98 gram. So we have written 98. So H2SO4 molar mass is 98. The number of H2 hydrogen replaceable, better you can go through its structure, I will discuss it. So equivalent mass of sulfuric acid H2SO4, that will be 98 and divided by 2 is of 49. So here the equivalent mass of sulfuric acid is half of its molar mass, that is 98 divided by 2, because the number of replaceable hydrogen atom is 2, or we can say the basicity of sulfuric acid is 2. You can also express in terms of another way. We can express it in terms of the structure of sulfuric acid also. When we draw different methods to draw the structures, so sulfuric acid S, this double bond O, this double bond O, OH is again OH. This is your sulfuric acid H2SO4, right? So number of H plus ion, or better we can say protonated oxygen atom. Another terms I am including here, कि how many protonated oxygen atoms are there in an acid, that is equal to the basicity. And so the protonated oxygen atom means कि कौन सा कितने ऑक्सीजन एटम है जिसके साथ में आपका हाइड्रोजन अटैच्ड है. प्रोटोन मीन्स हाइड्रोजन अटैच है. तो यहाँ क्या लिखा हमने, सल्फ्यूरिक एसिड का स्ट्रक्चर बनाओगे आप, उसमें कितना ऑक्सीजन के साथ में हाइड्रोजन अटैच है उसकी बात करोगे. तो यहाँ 2 है, तो उसका जो बेसिसिटी होगा सल्फ्यूरिक एसिड का वो 2 होगा. सो इक्विवेलेंट मास जो होगा दैट इज मोलर मास डिवाइडेड बाय 2. इट्स स्ट्रक्चर कैन ऑल्सो बी withdrawn like that. You have written so many different examples are there, SOH, different ways to represent OH. The sequence is same, but the way of representation is different, right? So हमने क्या बताया कि अगर कोई बेस होगा तो उसका जो इक्विवेलेंट मास होगा दैट विल बी डिवाइडेड बाय द एसिडिटी ऑफ बेस, मोलर मास डिवाइडेड बाय एसिडिटी ऑफ बेस. In terms of acid, that will be divided by basicity. There are certain examples in which the basicity, the hydrogen is different, but the basicity is different. For example, I would like to quote you H3PO4, right? H3PO3, both having 3 hydrogen atoms, but the protonated oxygen atom is 2 and 3. In case of what I am telling, in case of H3PO4 and H3PO3, the number of hydrogen atom is 3, Here is also the number of hydrogen atom is 3, right? But the protonated oxygen atom in this case is 3, in this case is 2. So this basicity of H3PO3 is dibasic. It is called dibasic, and this one is tribasic. That depends upon the structure. If you don't mind it, I am going to draw the structure of this one, right? The structure of H3PO4. What do you say? Phosphorus in the center is OH atom, again OH atom, this OH atom. Hydrogen atom is 3, oxygen used is 3, and this fourth oxygen is like that. So number of bonds by which phosphorus atom is surrounded should be 5. The number of protonated oxygen atom is here is 1, 2, 3. But if you draw this H3PO3, what we observe? P, OH, again OH, oxygen, this is your hydrogen. Because the number of bonds would be 5. So here the number of bond is 5. But you talk about this protonated oxygen atom is only 2. So basicity of phosphorus is of this acid is 2, in that phosphoric acid is 3. Right? Clear? Now, if we have some salt, suppose we are going to calculate only the equivalent mass. So if the equivalent mass is calculated of in salt, then you have to see the charge on cation. How many charge on cation is there? Just I have written here magnesium chloride, right? So you have to calculate the molar mass of MgCl2, right? You calculate it. Magnesium is 24 plus 2 into 35.5. So is 71 plus 24. So 24 plus 71 is 95. Am I right? So is 95 is the molar mass. Charge on magnesium, if you remove this, is 2 plus charge. And therefore, equivalent mass of magnesium chloride will be 95 divided by 2. Right? So if there is any salt, say how you have to calculate the equivalent mass? So molar mass divided by the charge on the cation part. Right? So these are some different ways to express the concentration of solutions. You have to solve some numericals also, how to solve, and what you have to do is the basic way to express the concentration of solution. Right? So I think for today it is enough. You must go through my YouTube channel, and I will try to describe in a different way, in a calculative manner, all the chapters which are included in the syllabus. I will discuss one by one. Okay, so thanks for today.